a talk to your neighbor and re-express, there should be some questions about something that didn't make sense. Not everyone got this right. So something should still be confusing. Please, you don't have to admit to me that you were confused. Pretend that your neighbor was confused. Go on, rat your neighbor out. What's hard here? Okie dokie. Well, let's see if you could do it with the harder version. Uh, I did a scaffolding problem, a building up to problem for the 3 o'clock class, but more people are getting more of these subparts right. More people are getting more of these subparts right. So let's see if we can jump. If you guys struggle too much, well, I'll give you a shortcut here. But why don't you wrestle with this guy? Hint, this has more than one part. You must build up to this using the techniques I introduced last class. Pieces, write down pieces. What do you know? What can you find out? Yeah. Talk to your neighbor with this one. You will need to work together. And if and when you come up with the final answer, put her in what, G? I'm going to give you guys 7 minutes to wrestle with this and see how we're doing. Oh, by the way, perfectly smooth means no friction. FYI. Gesundheit. Who's just stuck?
I'm stuck.
Who's still working productively? Oh, wait, who's done? Okay, well, let me just check the dones real fast. Okay, so about a third of the dones are correct. Let me give some hints here. Here is the Tucker guaranteed step-by-step, shine your teeth, lower your golf score, and I don't know, get your answers right method. What did I say in lecture last time? Draw a bubble around the object under study. There are two kinds of forces that can interact with object and bubble. The weight force and anything that passes through the bubble. So there are two things that act on this. What are they? The Earth exerts a weight force and B exerts a normal force. Which direction are these forces? Which force acts downward? Caused by caused by the Earth. I want you to identify the thing. Then normal force acts upward. Yeah, like always, right? Does normal force always act upward? Does normal force always act up? No, 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 no. What is a counterexample for normal force acting upward? Anyone tell me a counterexample of normal force acting upward? Hint, hint, hint. Counterexample to normal force acting upward? The Tucker is pressing the table downward with a normal force. How do I know that I'm pushing downward on the table? Sure, I'd say Newton's third law guarantees it. If the table supports me with a normal force, I must oppress him to the same tune with the same kind of force. Okay, anyway. What's the magnitude of the weight force? Don't say 1 kilo. There's the magnitude of the weight force. Yeah, hanging around that to 10 because I don't have a calculator. 10 newtons, 10 odd newtons. Yeah, properly 9.8 newtons. What's the magnitude of the normal force that B exerts on A? It has to be the same. Why? Newton's first. If you ain't accelerating, your forces must be in balance. They're all trick questions until they click, and then they're all easy questions. Okay, step dose. Analyze this sucker. I've drawn a bubble. Tell me what objects interact with B, which direction, what kind of forces, and solve. I'm gonna give you another 2 minutes. You see it? Good. It's what I live for. Not always. For instance, so what do you mean? That's a true statement, yeah. But it's not true that all things in contact always exert normal forces. Weight force on what? Normal force on what? Yes. Yes. That's true. That's completely correct. Very importantly, A does not exert weight on B. Lots of students will goof in this, say that A pushes on B with weight. It does not push on B with its weight, it pushes on B with a normal. How do I know that? Weight is exerted between planet and object. Only the planet, Earth, can feel those that WAE, Newton's third law pair. Now, it is true that normal force of A on B is 10 newtons down. That's a different force. It's a different cause. It's a different type of force than WEA. What? On what object? Okay, the normal force of A on B, and what else would you add to that? This diagram is just for A. Those forces only belong on A's diagram. One of those forces is a partner on B's diagram. Okay. Who's stuck? Who's still working productively? Who's done? Okay, here we go. Here is the way. This is A's diagram. Wow. This is A's diagram. Here's B's diagram. I don't want that to look like a vector. I'm going to draw that in a separate arrow just to make it clear that I'm not drawing an additional force. There is no force. The reds are not forces. Okay, there are 3 objects interacting with B. Did everyone get 3 objects? There should be 3 arrows on your diagram for B. What objects interact with B? A, C, and planet. Which way does the planet exert a force? Weight force of Earth on B to the tune of 30 newtons, yeah? Now there's a normal force upward exerted by what? By what? What pushes up? C pushes up. C supports B. 30 newtons, right? Those are balanced. We're done, right? Are we done? What did I miss? A. How do I know A pushes down? Because B pushes up. If B supports A oppresses B. Normal force has to have a partner. NBA, NAB, 10 newtons. So what's the net force? 30 up, 40 down. Is this guy accelerating? Why not? Doesn't normal force always equal weight force? You see that? There's 30 plus 10, 40 down, 30 up. Shouldn't we be accelerating? Doesn't normal always equal weight? How much normal pushes up on it? 10 newtons pushes down from A. If this guy were 10 newtons, then we'd have 40 down, 10 up. I would definitely not be in balance. What am I missing? What did I lie to you about? Where's the lie? No one sees the lie? Okay, let's check step by step. Are there 3 things interacting with object? Yes. Is weight one of them? Is my formula for weight correct? Is NAB a force? Is its magnitude correct? Are you sure of all of these answers? What must be wrong? Where's the lie? What must normal C on B be? Exactly. How does C know that it has to exert 40 newtons up? But how does it know? How does it know that we want not to accelerate? I take that. I would say that at a deeper level, normal forces are forces of constraint. We deduce their magnitude and direction based on logic and reasoning. the forces, the actual interactions themselves, are not our models. In truth, actually, all of these forces except for weight or electricity. Talk about that next semester. Yeah. Okay. We'll get there. So how does it know? It has its ways of knowing, but we deduce based on understanding that it's not accelerating. So it must be in balance. What about C? What interacts with C? C interacts with table. Which way? Table pulls C down? Up. Think about it. A very common mistake is to think about what does the table feel. The table does feel pushed down, but put your mind, if you're studying C, put your mind in the perspective of C, not anything else. Okay? So if I'm thinking of C, which way do I feel pushed by the table? Up. What's the magnitude of NTC? I don't know yet. Let's figure it out. What other forces must be exerted on C? A B acts on B. NAB and NBA are a pair of forces, and CB and NBC are a pair. Yeah, you see that? No. Questions. Turn to your neighbor and express why this is NBC instead of NAB. Your turn. I asked what other forces act. The downward force, someone said NAB. Why doesn't NAB act on C? Perfect. NAB and NBA are interactions between A and B. C can't feel A touching B. C can't feel B touching A. Forces are interactions between two things, and a third thing cannot feel that force. It can feel another force, which is affected by the other forces on other bodies, but C can't feel a force on A, nor a force caused by A. C is not in touching A. And can feel the third law pair NCB, NBC. Question. The subscripts are always what causes the force, what object causes, what object feels the force. So I've been saying normal force of B on C, the normal force caused by B and felt by C. Other question? Yeah. And TC, the normal force that the table exerts on C. What's NBC? 40. How do you know it's 40? Well, we calculated NCB. Who guarantees that NCB and NBC are the same? Third law, Monsieur Isaac. Not a very French man, actually. Okay, what else? What else is interacting? Are we done? Wait for what? Weight force of Earth on C. Weight force of Earth on C, 50 newtons. What's the table on C then? What's it gotta be? 90. 50 plus 40 is 90. You gotta balance your ups and downs. If you're not accelerating. If the table isn't breaking, if the table breaks, everything changes. Or if the table's on a rocket ship that's accelerating upward, everything changes. I'm assuming they're just sitting there though. think you're now ready to go to the original problem that I challenged y'all with. Two boxes. Two boxes horizontally. Now we do have acceleration. In the interest of time, I'm going to point out, I done did a diagram. A hand pushes 3 into 5. What is 5 feeling a force from? Anything else? Forget the vertical. What is 3 feeling? 5 in hand. Okay. You don't know the force between the boxes yet. Make a symbol for him. Not that kind of symbol. Make a letter to represent him. What's Newton's second law say? Total force on an object equals its mass times its acceleration. Ready, set, go. See if you can find the force that they push on each other with. This would be question L. Okay, we have two objects. We're going to apply Newton's second law twice. What does Newton's second law say for the 5 kilo object? Here's his diagram. Net force equals mass times acceleration. What's his net force? There's only one force. No, if I'm talking about object box 5, the 32 don't touch the 5. I told you a minute ago, you don't know him, so make a symbol for him. There's Newton's second law. The net force acting on object 5 is the mass of object 5 times the acceleration of object 5. I don't know the acceleration yet, so I left a symbol. This is the principle of algebra. What's the second law for box 3? Put this in Google form M. Give me the Newton second law applied to box 3. You don't have numbers, so use letters. We have some numbers. We'll come back to L, by the way. Answer my question first here. I'm guiding you up to L. What? M's question is I just wrote the second law for box 5. This is F equals MA for box 5. Now you write F equals MA for box 3. What is the net force? What is the mass? What is the acceleration? Equation. Show me the equation. Show me you can set up the equation. Okay, so there are two forces acting on box 3. What are they? There's a 32 Newton force forward, and there's an unknown N Newton force backwards. How do I write the total if I've got 32 going this way and N going that way? 32 minus N, why? How come I don't put a plus sign? They're against each other. If you want to put a plus sign, think about this. Have one classmate push your shoulder with 100 newtons. Have another classmate push your other shoulder with 100 newtons. Is your net force 200 newtons? Are you flying? No, you're just squished, right? The net force would be 0. 100 one way plus 100 the other way balances to 0. Net force here is 32 minus normal force of 5 on 3 equals what's MA? Why can't I use the same A for both equations? How do I know that they accelerate at the same rate? I would, yeah, you're on A track. I would put it as if they have different velocities, are they still going to be pushed together? If they're moving at different rates, are they going to still be pushing together? Isn't one going to be zooming off? Would that happen? Would it happen that you push two things and the other one goes shoo? That doesn't happen, right? That's not everyday experience. So the objects must be stuck together. They must have the same velocity. They cannot have different accelerations if they have the same velocity. Great, I've got two equations and two unknowns. N53 equals N35. Solve, find N. You did this earlier. Now find N. This is question L. Again, let me write this. N equals 5a. 32 minus n equals 3a. Here, Newton's law is applied to each object. Find me n. Principle of substitution. 32 minus 5a equals 3a. I want like terms to be together, so I'm going to get rid of the 5a. Oh, look, like terms, I can combine them. 32 equals 8a. I guess acceleration is 4 meters per second squared. Is that what I asked for? No, but I can shove him back up there. What's 5 times 4? 20 newtons. I think a whole bunch of you are almost there, but not quite. I think there's still a bunch of questions. We are at the end of the class period. I will stick around for however long it takes for anybody who still wants to push till it clicks. Oh, also, homework is up. Sorry it took so long. I made it shorter.
N35 and N33, but over there you take 35, 33 out.
Newton's law says they must, third law says they must be equal. So I stopped writing the subscripts because I'm lazy. To make sure that people are thinking clearly about what pushes on what. If you don't write the subscripts at all, if students start by just writing ends all over the place, then they'll include forces that objects exert on themselves and forces that don't have an object to exert them. They'll just make up random things. So if you do these subscripts, it forces you to think clearly about what interacts with what. At the end of the day, when you plug in, if two things are equal, you can use the same letter. Getting there?
A little bit. I got the acceleration earlier, and then I just didn't put it on
We've got
right there.
about a month of this. Give it time. Do the homework. See if it solidifies. Yeah. Yep.
Friday.
Yep. It's up. Sunday. Yeah. You look dazed. Question me. It's got my son's hair, actually. Sure. Put it up in my office. Actually, yeah, I'll go put it up in my office.
That's what you were drawing.
Wait, no, give it to me on Monday. Give it to me on Monday if you remember. Excuse me. You okay? You better? What'd you have?